Alright, so welcome to the video lecture series on Introduction to Computer Networks. And today our topic is going to be the common protocols that we see on the internet. So we'll start off by by understanding the network and port address translation protocols. The NAT stands for Network Address Translation, and PAT stands for Port Address Translation. So a quick review on public and private IP networks. We know that private IP networks are formed using the private IP ranges, which are defined in these three segments. These IP addresses are guaranteed that they are not unique and they are not registered so that they can be accessible from the public internet. And on the other hand, public IP networks are globally unique IP addresses which are expected to be accessible from the internet. So from that perspective, let's try to understand what network address translation, or the NAT, does for us. So the NAT allows us to connect multiple computers which are placed in a private network to be able to connect to the external public network. And we know that private networks, they have a range of private IP addresses, and public networks, public IP addresses are unique. So how can we enable the connection of private IP addresses into the public network using one single IP address? That is the purpose of the NAT, and it enables hosts on private networks to communicate with hosts on the internet. The idea is that it allows IP addresses in the private network to be changed without notifying the public internet, because it's something that is happening on the private side. On the other hand, it also allows the ISP to be changed, which is on the public side, without changing the private network settings. On top of everything, it also protects the internal private network by enhancing the security, because the private addresses are not explicitly visible nor addressable from the internet. So a quick idea on the NAT protocol. If we have the default gateway, which is NAT enabled, and on the right we have the private network, and on the left we have the public internet. So the default gateway on the inside interface will have a private IP, which is assigned from the private IP ranges. And on the other hand, it has a public IP on the other interface, which is globally unique. So therefore, any packet which has a source and destination in the same network, the private network, will be using this part of the network and will reside on the right of the default gateway. So it never leaves into the public side of the network. However, on the other hand, if any of these hosts, which are located on the private side, if they intend to access anything on the public internet, so all packets leaving the private network will have different source private IP addresses. However, we'll have the same source public IP address. So what happens is that the default gateway replaces all of these private IPs with the public IP whenever a packet goes outside into the public domain. So the basic NAT actions for outgoing packets is that it would change the private source IP of outgoing packets into the public IP of the NAT enabled default gateway. In addition to it, it also saves this particular information in the NAT address translation table. So this is a table which maintains the records that whatever hosts on the private side is accessing the public internet, and which IPs have actually been converted to the public IP. Next, at a later time, for any incoming packets which are let's say, for example, a response from the internet, the default gateway, which is NAT enabled, will change the destination public IP of the incoming packets into the private IP of the private network host. And this it does using the records that it has stored in the NAT translation table. So whenever it is going out, it switches the private IP into the public IP, and whenever anything comes back, it switches it back from the public IP, the destination switches from the public IP into the private IP at the NAT server. However, there's a basic problem with the basic NAT. The thing is, let's say 2 or more devices in the private network are trying to send out a packet out of the internet, and both of them will have the same source IP when sending packets out of the internet, and both of the sources would be the public IP address of the default gateway. So therefore, whenever they are receiving the responses, the incoming packets from the internet for the 2 different hosts cannot be distinguished because both of them will have the same destination IP on the public side, and the NAT server will be confused that which packet should be routed to which host. To solve this problem, we have the concept of port address translation. It's also called dynamic NAT, and the reason why we call it dynamic because it uses both IP addresses and port numbers together for incoming and outgoing packets so that it can identify the separate hosts from the on the private side which we're trying to reach out into the public internet. So the dynamic NAT maps multiple source local addresses and ports into a single global IP address, but with different ports. So therefore, multiple incoming packets, they can have the same destination public IP, but because the port is unique, they can now be distinguished. So let's see how this works in terms of the dynamic NAT actions. So first of all, for all outgoing packets, the NAT server will replace the private source IP and the port to the public NAT IP and a new port. And this particular translation that the NAT server did, it will save it in the NAT translation table. Eventually, at a later time, for the incoming packets, the NAT server will replace the public destination NAT IP, which is on the internet side, and the port that the packet is targeted for. It will replace these two with the destination IP of the private side with the port, using whatever record it had previously stored in the NAT translation table. So let's just take a quick look at how this would work. So let's say, for example, we have this particular setup where the private network has 3 hosts, 10.001, 002, 003, and the private side of the default gateway, which is NAT enabled, is address 10.004. However, the public side of the default gateway has a globally unique public IP 138.76.29.7. So if the host 10.001 wants to send a packet out onto the internet to address 128.119.40.186 and on port 80. And this particular address this 128 address, this is an address which is located on the public internet. So this packet will be routed to the default gateway so that it can head out to the public side of the network. And at that point, the default gateway will take a look at this packet and then translate or replace the source address of the outgoing packet with the public IP address of the default gateway. So if you see here, originally the packet had source 10001 and originated from port 3345. However, when the default gateway forwarded it, it translated it to the public IP address of the default gateway, which is 138.76.27.7. And the port 5001 is dynamically allocated and is different every time a packet is sent out. So the NAT router changes the source address from the private address and port into the public address and a new port, and saves it into the NAT translation table. The table, as you can see, has two parts: the WAN side, which is the public internet side, and the LAN side, which is the private side. And it has this pair of IP address and port for outgoing and incoming packets, which will be used at a later time. So next, if there is a response packet which comes into the default gateway, which has a destination of 138.76.29.7 and port 5001, the NAT-enabled default gateway will look at the NAT translation table and see that the outgoing packet it actually encountered earlier, it changed it to 5001 port, and the corresponding LAN side port and IP is this particular record. So what it'll do is that it will change the destination address of this particular packet from 138.76.29.7 and port 5001 to the LAN side IP address and port, which is 10.0.0.1 and port 3345. And it is able to do this particular translation based on the record that it has already saved in the NAT translation table.